Hey guys, so we made it to the last lesson of the chapter and of the school year. All right, so we're going to look at graphing cosecant and secant functions, which are two of the more challenging. They just take a little bit more work to graph, but we'll get through them. All right, so in order to graph cosecant, you're going to start by graphing sine, because remember, sine and cosecant are reciprocal functions, okay? So we're going to graph sine, and we know the parent function for sine. I'll do it down here. Y equals sine x. Okay, hopefully you have this one memorized by now. So the x values are 0, pi over 2, pi, 3 pi over 2, and 2 pi. And for sine, it's the values are 0, 1, 0, -1, 0. All right. So then to get cosecant, since it is the reciprocal of sine, we just flip those values. Okay. So for cosecant, the x's aren't going to change. So that's going to be 0, pi over 2, pi, 3 pi over 2, and 2 pi. So like I said, it's a reciprocal. So maybe we should remind ourselves for sine, the ratio is y over r, and we're in the unit circle. So the radius, the r value is 1. Okay, so in order to get a 0 there, it was 0 over 1, right? This was 0 over 1. This one was 1 over 1. This one was 0 over 1. Here I had -1 over 1, and then 0 over 1. So these are what we need to flip. Okay, so when I flip, I'm going to have 1 over 0, which is undefined. Then I'm going to have 1 over 1, which is still just a 1. Then I'm going to have 1 over 0 again, which is undefined. And then I'm going to have, where am I? Here I am. 1 over -1, which is still just -1. And then I'm going to have 1 over 0, which is undefined. We're going to have to extend the table because we don't have enough points yet to graph, to plot. Let's see if turning a light on is better or worse, depending on the time of day. All right, so I'm going to extend by using the pi over 6s. So I'm going to have pi over 6. I'm going to have 5 pi over 6. Then I'm going to have 7 pi over 6. And 11 pi over 6. All right, so remember here, if sine is y over r, for cosecant, it's r over y. All right, so the r value is always going to be 1. So for all of these, it's going to be 1 over something, 1 over something, 1 over something, 1 over something. And the y value, again, comes from the unit circle. So let's go to the unit circle, and we're looking at pi over 6. All right, so the y value of pi over 6 is 1/2. So it's going to be 1 over 1/2. Then I'm going to go to 5 pi over 6 over here. The y value is 1/2. Then I'm going to go to 7 pi over 6. The y value is -1/2. And then I'm going to go to 11 pi over 6, and it's -1/2. All right, so I have 1 over 1/2, 1 over 1/2, 1 over -1/2, and 1 over -1/2. All right, we can't leave them as complex fractions, so we'd have to multiply by the reciprocal. So I'm going to have 2, 2, -2, and -2. Okay. And the next thing I would need to do is graph. So I'm going to graph actually both the sine and the cosecant function. To figure out my x-axis, I look for the smallest fraction, and it looks like pi over 6 is the smallest. So I'm going to count by 1/6. So I have pi over 6, 2 pi over 6, which is pi over 3. Then it would be 3 pi over 6, which is pi over 2. That would be 4 pi over 6, which is 2 pi over 3. Then I'm going to have 5 pi over 6, 6 pi over 6, which is pi. But I have to go all the way out to 2 pi, so I have to keep going. So that was 6 pi over 6. Then I have 7 pi over 6, 8 pi over 6, which is 4 pi over 3, 9 pi over 6, which is 3 pi over 2, 10 pi over 6, which is 5 pi over 3, 11 pi over 6, and then 12 pi over 6, which is 2 pi. Alright, now if you can't simplify the fractions that quickly in your head, obviously write them out and then go back and simplify them. For my y's, I have to go up and down to 1 and -1, and then over here 2 and -2. So I'm going to go 1, 2, 1, or yeah, -1, -2. All right, so I'm going to first graph my parent sine function, 0, 0. Then I have pi over 2, 1. Then I have pi 0. Then I have 3 pi over 2, -1. And then I have 2 pi 0. Okay, so here is my parent sine function. All right, and then finally, I'll graph my cosecant function. So I have a point, I have an asymptote. Let's put those in. The asymptote is along the y-axis. And then I have another one at pi. And then I have another one at 2 pi. Okay. And then, let's see, I'll use black, I guess. I'm going to plot a point at pi over 2, 1. Pi over 2, 1. Then another point at 3 pi over 2, -1. 3 pi, what am I saying? 3 pi over 2, -1, right here. All right. And then I have pi over 6, 2. 5 pi over 6, 2. 7 pi over 6, -2. And 11 pi over 6, -2. Okay, so you try to hug your asymptotes, but don't cross them. All right, and there you go. And the period for our cosecant graph, okay, the period is 2 pi. And there you go. There's your cosecant graph. All right, let's do a secant graph. Actually, you know what? To save time, I'm going to do a transformed cosecant graph because I have all this data up here, and then we'll move on to secant. So I'm going to kind of go out of order from the notes a little bit, but that'll just make it easier so I don't have to rewrite all this data again for the transformed graph. Okay? So, when you go to transform a graph, it's going to be helpful to have the parent functions up here. Okay, so I'm going to have, which one did I want to do? Sorry, I'm trying to find the right graph. No, not that one. This one. Yes, no. No, not that one. This is the one. There we go. All right, so I want to graph g of x is equal to 2 cosecant pi x. Okay, so I think for the transformed ones, I'm just going to get the table. I think hopefully at this point you're understanding how to plot the points and make your x-axis. So just to save time, I'm just going to get the table. Okay, so in order to get the table, we want to have the parent sine function up here, which we have, and also the cosecant function, which we have. Now, it's actually going to be very helpful as well to transform the sine function based on this transformation. So we're going to have the vertical stretch of 2 and the horizontal shrink of 1 over pi, okay? So what I mean by that is underneath my pi function, or my sine table, parent function, I'm going to write y equals, and just like it's 2 is the a and pi is the b, I'm going to write 2 sine pi x. And I'm going to look at what that table would look like with those transformation rules. All right, so I know that my a value means I'm going to multiply all my y's by 2, and I'm going to multiply all my x's by 1 over pi. So all of these have to be multiplied by 2, so it's going to be 0, 2, 0, negative 2, 0. 0, 2, 0, negative 2, 0. Okay? And then all of my x's have to get multiplied by 1 over pi. So it's going to be 0, and then this times 1 over pi is going to be 1/2. And then this times 1 over pi is going to be 1. And this times 1 over pi is 3/2. And this times 1 over pi is going to be 2. All right, the reason we want this graph is because we're going to actually want to plot that graph in order to help us graph the cosecant one. All right, so for cosecant, same transformations that I did over here, but now to the cosecant table. So all of my cosecant y's have to be multiplied by 2, and my x's have to be multiplied by 1 over pi. So now looking at this table and doing the multiplication, I'm still going to be undefined. Where I'm undefined, I'm just going to put a u. Multiply by 2, undefined. Multiply by 2, undefined. All right, continuing my table. Multiply by 2, multiply by 2. All of them being multiplied by 2 is 4, 4, negative 4, negative 4. All right. And then for my x's, I have to multiply all of these by 1 over pi. So it's going to be 0. It's going to be 1/2. Multiply pi by 1 over pi is 1. Multiply 3 pi times 1 over pi is 3/2. And then multiply 2 pi times 1 over pi is 2. Continuing, multiplying pi over 6 times 1 over pi is 1/6. Multiply 5 pi over 6 times 1 over pi is 5/6. Basically, the pi's are just going to cancel each time. So it's going to be 7 over 6, and then 11 over 6. So when you go to graph, in order to have that nice sine curve, which helps you graph your cosecant, you're going to want to graph this one and this one. Okay, so it is a lot of work to get the right data in order to graph. All right, and just to show you what it would look like. So this one here is your transformed sine function, and here is your transformed cosecant function. Okay. All right, guys, we just have one more type of graph to look at, and that's going to be the secant graph. And the process is the same, just different data values. All right. So, get the right thing up here. So secant is where I am now. Okay, so in order to graph y equals secant x, you're going to start by graphing y equals cosine x. Okay, so we have our parent function y equals cosine x. Remember, as far as the ratio is concerned, for cosine, it's x over r, right? And if I'm in the unit circle, here at 0/2 pi, the point is 1, 0. Here at pi over 2, the point is 0, 1. Here at pi, the point is -1, 0. And here at 3 pi over 2, we have 0, -1. Okay? So for cosine, when I come up with my table, quick little review as to where the points come from, I'm going to use 0, pi over 2, pi, 3 pi over 2, and 2 pi. I said it, but didn't write it right. Hold on a second. 3 pi over 2, and then 2 pi. Okay. So remember, the radius, the r value, is always going to be 1, and I'm taking each of these x values. So it's x over r, 1 over 1, 1 over 1, which gives you a 1. Then it's x over r, 0 over 1, which gives you a 0. Then it's x over r, -1 over 1, which gives you a -1. Then it's x over r, 0 over 1, which gives you a 0, and then again 1 over 1, which gives you a 1. Okay? All right, so then I'm going to reset unit circle because I need that space. Okay, so then for the secant, y equals secant x, since they are reciprocals, the x's aren't going to change. 0, pi over 2, pi, 3 pi over 2, and 2 pi. All of these need to flip. Okay, so it's going to be 1 over 1, which is 1. 1 over 0, which is undefined. -1 over 1, which is -1. 1 over 0, which is undefined. And 1 over 1, which is 1. Now again, we need to extend this table because we won't have enough data points for plotting. All right, and for secant, we're going to use pi over 3. And there is a reason why here we use pi over 3, and on the other one we use the pi over 6s, and it's because the values come out nicely. We could use any of the value. We could be using pi over 6s for this one, but then they're not going to be nice points to graph. Okay, so pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. All right, so if I go to, use my unit circle again. If I go to pi over 3 on the unit circle, pi over 3, and remember, it's going to be, since we're doing the reciprocal, it's going to be r over x, right? 1 over something, 1 over something, 1 over something, 1 over something, 1 over something. I want the x value at pi over 3. So if I go to pi over 3, the x value is 1/2. And that's why I choose pi over 3, because if I wanted to choose pi over 4s to extend my table, then I'd be working with a radical. If I wanted to extend my table using the pi over 6s, I'd still also have a radical. So by choosing all the pi over 3s, I'm going to have 1/2, -1/2. Sorry, can you see it? Yes. -1/2 again, and 1/2. So it's 1/2, -1/2, -1/2, and 1/2. And when I multiply, 1/2. When I multiply by the reciprocals, I get 2, -2, -2, and 2. Okay? I'm not going to graph this one. For this one, I'll do the transformed one instead, okay, because I already graphed the secant one, or the cosecant one, so I think you're understanding how to graph, hopefully. All right, so let's do the last thing, which is a transformed function. So let me make sure I'm doing the right one. I'm going to do this one here. Okay, so we're going to look at g of x equals 3, hold on, there it is. Couldn't find it. 3 secant x. Okay, so in order to graph 3 secant x, I first want to graph 3 cosine x. So under the cosine table, I'm going to make another table, 3 cosine x. So basically, whatever the transformation is on the secant function, perform the same transformation on the cosine function. So the 3 means there's a vertical stretch of 3. So all of these y values have to be multiplied by 3. So y times 3. So it's going to be 3, 0, negative 3, 0, 3. So 3, 0, negative 3, 0, 3. My x's stay the same. So 0, pi over 2, pi, 3 pi over 2, and 2 pi. Okay, that is going to be one of the tables that I used when I go to graph. Okay, over here, now I'm going to perform that vertical stretch on the secant table to get my 3 secant tables. So x, y. I'm going to multiply all the y's by 3. So 3 times y. It's going to be 3, undefined, negative 3, undefined, 3. Just multiply all these by 3. Continuing, multiplying all these by 3, I'm going to have 6, negative 6, negative 6, and 6. Okay? The x's stay the same because there's no effect on the horizontal axis. So 0, pi over 2, pi, 3 pi over 2, 2 pi, pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. All right, so the next thing I need to do is graph. Okay, so if I take a look at all of my fractions to decide what to count by, it looks like I need to count by pi over 6, since I have denominators of 3 and denominators of 2. If I count by pi over 6's, I'll hit them all. Okay, so this is the last bit that we're going to do together. So I'm going to count by pi over 6, 2 pi over 6, which is pi over 3, 3 pi over 6, which is pi over 2, 4 pi over 6, which is 2 pi over 3, 5 pi over 6, 6 pi over 6, which is just pi. I have to go out to 2 pi though, so I have to keep going. 7 pi over 6, 8 pi over 6, which is 4 pi over 3, 9 pi over 6, which is 3 pi over 2, 9 pi, 10 pi over 6, which is 5 pi over 3, 11 pi over 6, and 12 pi over 6, which is 2 pi. Again, if you can't simplify that quickly in your head, just write them out. All right, and it looks like I have to go up and down to negative 6. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay, so again, I'm just graphing the 2 green ones. I'll start with my cosine. So I have a point at 0, 3. Oh, I didn't put those values on. I didn't think to put those values on. Oh, yes, I did. That's on the y-axis. Sorry, guys. 0, 3 is here. And then pi over 2, 0 is here. And then I have pi negative 3, which is pi negative 3, which is here. And then 3 pi over 2, 0, 0 there. And then we have 2 pi 3. 2 pi 3. Oh, this is not right. Sorry, guys. I'm just noticing 2 pi over 6. It's like that point is too close. Why is that so close? That's a pi over 6. I don't know why I wrote pi over 2. Okay, there we go. So when I draw my graph, there is my cosecant graph. Last thing I have to do is draw my secant. So I'll start with my asymptotes at pi over 2. And then one at 3 pi over 2. All right, and then I'll plot a point at 0, 3. And another point at pi 3, or pi negative 3, and then 2 pi 3. All right, and then pi over 3, 6. 2 pi over 3, negative 6. 4 pi over 3, negative 6. And 5 pi over 3, 6. All right, so this is the shape of the graph. And even though we don't have the other sides, you could draw them. You could sketch them in if you want, since you know what the shape of the graph is supposed to look like. We did it. We made it through all of Algebra 2, partly in school, partly remotely. Go ahead and jump on to do your last homework assignment or one of your last homework assignments, because we still will review for the test and take the test. Let me know if you have any questions. Thanks, guys. Bye.